Assalamualaikum students, I hope you are all doing well. I have made this video so you can take help from this video to understand the working of subnetting and how can we divide an IP address to multiple IP addresses, as this process known as subnetting. So for subnetting we will be using for some terminologies and some formulas as well. So let's have a look on these formulas first, and then we will be moving to some examples of class A, class B and class C IP addresses and their subnetting process. So first of all, we will be using N and H. N is for network bits and H will be for number of host bits. And the formula to calculate the number of subnets will be 2 raised to power n. And similarly, formula for number of hosts per subnet will be 2 raised to power h minus 2. Why we are subtracting 2 from this formula? Because we will not be using broadcast IP, and at the end of every subnet mask address we reserved that IP address for multicasting. So we are subtracting -2 from this formula, which means that we are eliminating the broadcast IPs. So next thing is our block size for the subnet. So block size is basically the range of subnet mask address, that how many steps we are moving forward with each subnet mask, right? So these are the basic formulas used for subnetting. So I think let's move with our first example. So in this example I have written class A IP address. As we know that if the first octet starts with the number between range of 0 or 127, we can say that that specific IP address belongs to class A. So right now this IP address belongs to class A because number is within the range of 0 to 127. So by default subnet mask of class A is 255.0.0.0. This means that class A has IP address and which is 255.0.0.0. It means that its first octet belongs to network part and remaining 3 octets belongs to host part. So if we convert these decimal numbers to binary number, then we will be getting all ones for 255, and for 0 we will be getting all zeros for 8 bits, right? So in networking we denote N for 1 for network bit and 0 for host bit. So this is the by default subnet mask for class A. So you can see that I have used /10 here, which means that CIDR number, which means that classless interdomain routing number is 10. What is 10 in this specific scenario? 10 is basically total number of network bits we are going to use in this specific subnetting task, right? So by default for class A we can only have 8 network bits, right? But if we are adding 2 more network bits, we have to change this subnet mask such that in next second octet we are borrowing 2 host bits and we are converting those bits to network bits, right? So we have first octet and its total number of network bits are 8, and then 2 bits from octet 2 which we have borrowed. So you can see that we are making changes on in only second octet. The other octets will remain same. First octet will remain same, third octet and fourth octet will also be same, but as we are borrowing bits from second octet, so we will be making changes in second octet only, right? So let's move to the next step, which is to calculate the decimal value of this octet now. So we have to convert this binary number whole 8 bits to binary number. So when we calculate its decimal value, we will be getting 192, right? So now as we have discussed earlier that we have to calculate the block size of each subnet mask. So for that we are subtracting our decimal value which we have obtained from second octet. We will be subtracting this number from, so we will be subtracting 192 from 256. So we got 64 here. It means that our block size for each subnet mask will be 64. Now we will be calculating total number of subnets for this specific scenario. So total number of network bits we are basically borrowing from host part R2. So we have formula for calculating subnets which is 2 raised to power n. So the value of n here is 2, so 2 raised to power 2 is equal to 4. This means that total number of subnets we can create if we borrow 2 network bits. We can create total number of total number of subnets which are 4. So how can we check that which are those 4 subnets? First of all, we have to start each subnet from 0, and so total number of subnets in this scenario will be 2 raised to power 2, which is equal to 4. It means that we can create 4 subnets using this IP address if we are using CIDR value 10. If we change this number, and obviously there will be some changes here as well, so the number of subnet masks will also be, or some number of subnets will also be changed. So our first subnet will be 0. So keep in mind that we will be starting each subnet from 0. Then next one will be 64. Why? Because our block size is 64. So for third subnet we will be adding 64 in the second value, and similarly add 64 to the third value, and we will be getting final subnet. So we have got 4 subnets. Now how can we calculate total number of hosts in this scenario? As to calculate the total number of hosts, we have studied the formula 2 raised to power h minus 2. So let's discuss about that. So total number of hosts in our scenario, host bits in our scenario are 22, right? 6 bits are here, and we have 8 bits here and 8 bits are here. So 8 plus 8 16 and 6 22. You can also calculate by using formula like we have total 32 bits and we have 10 bits for network, and we can subtract 10 from 32 and we will be getting host bits. So for host bits calculation you can use formula 2 raised to power h minus 2. The value of h is 22, so you can calculate this number 2 raised to power 22 minus 2. I have wrongly calculated the number here, so I have hidden that number. You can calculate that number on your own. So we have also calculated the number of host bits. Now the next process is how can we write the addresses of these subnets. So as I have already told you that we are only making changes in second octet. So as we have calculated our hosts, are subnets which are 0 64 128 192. So we will be writing our first subnet as 90.0.30.70. Similarly, we are making changes in second quadrant, and we are getting the total 4 subnet masks which we have created using using this scenario. So this is the basic example of performing subnetting on class A address. So let's work on class B now. We have an IP address of class B. As we all know that if the first octet has decimal value between 128 to 191, so we can say that this address belongs to class B. And for this specific address I have written the value of CIDR is 17. So by default class B has subnet mask 255.255.0.0. that means that first 2 octets belongs to network part and remaining 2 octets belongs to host part. So if we convert these decimal numbers into binary, we will be getting this all 8 bits as 1. Similarly, second octet will be 1 as well, and remaining 2 octets will be 0 as they belong to host part. So this is the by default address for the class B. But if we mention here that we are using 17 bits for network, so by default we can only use 8 plus 8 16 bits for network in class B. But if we want to create more networks, we have to borrow some bits from host part and convert them to network, so we can extend this network to some more addresses. So I am writing here 17. It means that I am adding 1 bit in network part. So by default we have a limit of 16 bits, but I am adding 1 bit from host part as well, and we will be converting this bit from this bit to network bit now. So our new mask will be these first 2 octet will remain same, and we are making changes in the third octet, and this first bit which was host bit, we have converted that bit to network bit now. So in total we have 8 plus 8 plus 1 17 bits for network part now, right? So let's move to the next part, which is to calculate the decimal value of octet 3. So as we are making changes in the third octet, we have to calculate its decimal value. So its decimal value is 128. Now our next process is block size. So again we will be subtracting this number from 256 and we will be getting 128. It means that we have subnets of value of each interval of 128, right? So let's calculate the total number of subnets from this IP address, from this specific scenario. So the number of network bits we are borrowing from host bits is 1, so value of n is 1. So by using formula we have 2 subnets. So it means that we can create 2 subnets if we borrow 1 bit from host part, right? So what are those 2 subnets? To calculate that, as I have already mentioned, that for each subnet we will be starting from 0. So our first subnet will be 0 and we will be adding 128 to the next octet. So our next subnet will be 128, right? So we have calculated total number of subnets and we have also calculated their range as well. So let's move to the host part now. So as we have formula for calculating the host, total number of hosts for each subnet, so the formula is 2 raised to power h minus 2. In this specific scenario we have 17 bits reserved for network, so remaining bits will be for host. So we have total 32 bits in an IP address, and if we are using 17 bits for network, then we will be having 15 bits remain for host part, right? So to calculate total number of hosts we will be using formula 2 raised to power 15 minus 2. You can calculate this number. So we have also calculated the total number of hosts for each subnet mask for each subnet, right? So our first subnet will be 150.200.0.10. so you can see that we are making changes in this third octet. As we know that we could create only 2 subnets for this specific scenario, which were 0 and 128. So all other octet are same, but we are only changing the third octet, right? So this is an example for class B IP address and how we can convert an IP to multiple subnets, right? I hope you have got a better idea of subnetting now, and still if you have any question you can ask me so I can clarify those questions for you. And we will be having an assignment in next week regarding subnetting. I will be giving you some IP addresses with some CIDR value, and you have to convert those IP addresses to their subnets as well. So check this video and let me know if you have any question.